Okay, greetings. My name is Mhlanga, a student at EIT, presenting Energy Management Review presentation for my assignment. So this is the simulation of what would have been a presentation for management to be convinced in the review that I'm intending to do and the findings that I would have found in the review. So yeah, let's start by saying the presentation summarizes the energy management review of Alpha Manufacturing Plant. I will explain the scope and objectives and monitoring and control strategies, conservation actions, optimization opportunities, energy flow findings, and energy intensity results. The purpose is to show the plant can reduce energy waste, improve system performance, reduce peak demand, and strengthen energy management. Alpha Manufacturing Plant has several energy management concerns. This includes rising energy cost, peak electricity demand during afternoon production, poor visibility of use, inefficient equipment operation, limited staff involvement in conservation. The plant includes production machinery, pumps and fans, compressed air, process heating, steam services, HVAC, lighting, a small BMS, and a basic electricity and gas billing records. The case study shows that both technical and behavioral issues contribute to energy waste. The scope of the review is to identify where energy is being used, wasted, or poorly controlled across Alpha Manufacturing Plant. The review includes the major plant systems and energy users. The objectives are to reduce high afternoon peak demand, improve monitoring, reduce energy waste, improve equipment efficiency, support staff participation, and track performance using electricity use per ton of production. The monitoring is important because the plant currently has limited visibility of where energy is being used. The assessment identified monitoring points such as electricity use, production output, energy intensity, afternoon peak demand, pump and fan operating data, compressed air leaks, HVAC schedules, and lighting operations. This information helps the energy team move from assumptions to evidence-based control decisions. The Conservation Awareness Plan focuses on energy waste behaviors that can improve through communication, responsibility, and follow-up. Workshop lights should be controlled through switch-off checklists and assigned zones. Compressed air leaks should be recorded in a formal leak register and followed up by maintenance. HVAC should be scheduled through the BMS and only overridden when authorized. These actions will improve accountability and can reduce energy waste without major capital cost. The pumping system is a major optimization opportunity because the case study states that the main pump is fixed speed and flow is controlled by throttling. This means the pump produces more pressure than needed and the excess energy is wasted across the throttling valve. The improved design using a VSD, pressure or flow feedback, and a pump sequencing. So the pump output matches the process demand more closely. This reduces unnecessary energy loss while maintaining flow and pressure. So instead of having a throttling valve, we try to regulate our flow and pressure using the VSD by controlling speed, and sequencing would be a better option. Several other technical improvements were identified. The fan system uses dampers for a flow control, which creates pressure losses. The compressed air leaks are reported informally and should be managed with formal leak register actually. Damaged steam insulation causes heat loss and should be repaired. Process heating should be reviewed to reduce repeated heating and cooling. HVACs should use BMS scheduling and deadband control, while lighting can be improved through checklists or automatic control. High afternoon peak demand can increase electricity cost if total energy is unchanged. Demand monitoring and alarms can warn operators before the plant reaches a high peak. Staggered startups and load scheduling can prevent large loads from running at maximum demand at the same time. For HVAC, the existing BMS should be used to align operation with occupancy. Applied time overrides, use temperature deadbands, and avoid unnecessary startup or late operation. Energy intensity was calculated by dividing monthly electricity use by monthly production output. This is more useful than total electricity use alone because production output changes each month. The baseline period had an average energy intensity of 425 kilowatts hour per ton. The improvement period had an average of 395 kilowatt hours per ton. This represents a reduction of 30 kilowatt hours per ton and approximately 7.1% improvement. That's good figures. The graph shows that months 1 to 6 are clustered around 425 to 428 kilowatt hour per ton. After month 6, the values reduced to approximately 392 to 403 kilowatt hours per ton. This indicates a clear improvement in energy performance during the improvement period. The plant should continue monitoring kilowatt hour per ton monthly and investigate any further increase. This is a good improvement also. Priority actions should be based on impact, practicality, and the case study findings. Monitoring is the first priority because without measurement, savings cannot be confirmed. Pump optimization is a high priority because throttling is a direct energy loss. Peak demand control is important because afternoon peak charges affect cost. Compressed air leaks, HVAC scheduling, lighting behavior, steam insulation, fan controls should then be addressed as part of a structured action plan. In conclusion, Alpha manufacturing plant has both technical and behavioral energy issues. The technical issues are fixed speed pumping with throttling, fan damper control, compressed air leaks, damaged steam insulation, poor HVAC scheduling. The behavioral issues are lighting left on and informal reporting of energy waste. The energy intensity analysis showed that the plant improved by approximately 7.1%. To sustain this, the plant should continue monitoring, improve controls, reduce peak demand, strengthen maintenance, follow up, and involve staff in conservation actions. Thank you.